Hey guys, welcome to class. Today we're going to be learning about how to multiply monomials. So I'm going to explain how to do this with practice problems. Please have your class handout with you. If you don't have that because you're absent, please just take notes on a piece of paper so that you can attach it when you get back. So you may need a calculator, otherwise these are pretty small integers that we're working with today. You might not need one at all. You do need a pencil. So let's get started. So first of all, before we can do this, it'd be nice to know what a monomial is. If you remember from polynomial day when we classified polynomials, a monomial has just one term. So there are many different examples. You could have just a plain number. That's considered a monomial because it just has one constant. It's a number. It could also be a group of numbers or letters. So you could have like 3x. That's one group, so it would be considered a monomial. You could have a bunch of different letters or negative signs as well, like negative 8u to the 6th power v squared. This is one monomial because you have no addition or subtraction signs, you just have a negative sign. So a monomial is just a group of numbers or a single number that has variables or no variables, but it's just one group not separated by addition or subtraction. So this would not be a monomial because it has two terms. So monomial is just one term. So today we're going to learn how to multiply a monomial by another monomial. So when you multiply monomials, you need to know that you can regroup your monomials. You can split them apart and rearrange them in any order you'd like because it's all multiplication and you can multiply in any order. Just for proof here. 3 times x is the same as x times 3 because in the end you get 3x. Give you an example without a variable. If you had 2 times 3, isn't that equal to 6? Well, isn't 3 times 2 6? Yes, so that is why the commutative property of multiplication comes in handy here. You can rearrange your monomials or regroup them so that all your terms that are alike are next to each other. It makes it a lot easier. Because when you get to your coefficients, like your numbers before the variables, you just multiply them, just like normal. So you're thinking about your integers, same signs are positive, different signs are negative. You multiply your coefficients, and your beginning coefficient is going to be the answer, the product of the coefficients. When you have variables, though, you add the exponents, and that was one of our proficiencies from prior in the year. Just a reminder, when you have variables, the same variables, you can add their exponents, and we'll do some examples together. I think we're going to do about 8 examples, so we're going to get started right now. So this is our first example. If you look at your handout, it's letter E on your handout. But this has no coefficients. The coefficients are actually hidden here. So if you think of coefficients, those are the numbers before the variables. So I have a 1 and a 1. If I wanted to multiply those two together, I'd still get a 1. Since it is just a 1, I can just pretend it doesn't exist. I'm going to leave it for now. And then I keep my variables. My variable stays the same, and I add the exponents. So if you were to multiply this out, or think of what x to the third would be, it's 3 x's and then 4 more. 1, 2, 3, 4. So how many do you have in all? 1, 2, 3, 4, 5, 6, 7. So this would be x to the 7th power. A much faster way is to know your exponent properties. If you have a variable that's the same, you just add your exponents. This is one of our proficiencies this year, so that gets you to x to the 7th power. 1x to the 7th power can be reduced to your final of x to the 7th power. Let's try one now that has a coefficient other than 1. So on this bad boy, we have a coefficient here, a number before the variable, that's 3. The number that's before this variable is hidden. If it bothers you that there is no number there, I like to sneak in a 1. So you can draw yourself a 1, and then when you multiply your terms, your coefficients, you start by regrouping them. If this helps you, do it. You write your coefficients first, 3 times 1. And then you write your variables. So I have an x squared here and an x from over here. I can group these together. So I'm just going to think in my head, I'm putting parentheses around it. You don't actually need parentheses. I'm just grouping these together because I'm going to do 3 times 1 first. I get a coefficient of 3. And then I'm going to multiply x squared and x. Again, you don't need parentheses. I'm just trying to make a point that I'm going to group these together. I keep x's. If I have 2 and then I have 1 more x, remember that invisible 1, how many do I have now? I have x to the third. If you're not able to go from here to here, a smaller step would be to write out in expanded form, it's called, how many x's you have, and then count them up. I have 1, I have 2, I have 3, so that's x to the third power. This is your simplified answer. This is the product of your monomials, 3x to the third power. We're going to try another one now that has 2 coefficients. So pause the video if you need to digest, if you need to ask questions. Otherwise, let's keep going. So this one has 2 coefficients. We have a 2 and a 3. I like rewriting them so my coefficients are next to each other. It's a good starting spot. And then I'm going to group my variables next to each other. And if my variables are the same, I can combine them, but let's do the numbers first. 2 times 3 gets us a product of 6. When I have variables, if they are the same variable, the same letter, I can think of, well, that's the same as 2 x's and 1 more. Or if you know your exponent properties, you keep your variable and you add the exponents. This gets us a final product of 6x to the third power. This is called the product of your monomials. You took 2 monomials and multiplied them, so this is the answer of your multiplication, the product of your monomials. Well done. Nicely done. Going to get a little more difficult. I'm going to show you something new with 3 variables. So the variables are all the same, but let's put some coefficients in here just for the sake of argument. I'm going to sneak in a 1 before my terms. So that 1 helps me realize that when I'm multiplying the coefficients, I have 1 times 1 times 1, and then I have my x times my x squared times my x to the third power. So I can group my numbers all together and do 1 times 1 times 1 to get 1. And x, I have 1 of those. X, I have 2 more. And x, I have 3 more. If it helps you to write it in expanded form, I have 1x times 2 more times 3 more. And then I can count them all to see how many I have in all. 3 plus 2 plus 1. Or I can think I have 1 plus 2 plus 3. I have a total of 1x to the 6th power. That is fantastic to get there. But we can make this even better. So when you were adding polynomials the other day, I had you simplify. So we're going to simplify now. We're going to take away that 1 and just make it x to the 6th power. This is your final product of your monomials. All right, now what happens if I put it in parentheses? Don't let it scare you. Parentheses is just a grouping symbol. You usually see parentheses when you have negative integers. So don't let that make you scared or anything. This just says x to the 4th power times negative 3x squared. So again, I like to put in my numbers. This is going to have a coefficient of 1. I'm going to rewrite this so that my numbers are next to each other. And usually when you see this, you still keep grouping signs around your negative 3, and this is why. If I wrote negative 3 like this, it looks like 1 times minus 3. And this is actually 1 times a negative 3. So you'll most likely see parentheses around your negatives. And then I'm going to put my exponents next to my variables. X to the 4th power times x squared. Again, this is all multiplication, so I can rewrite it in any order. When you multiply a 1 times a negative 3, when you have signs that are different, you get a negative product. So this is going to be a negative 3, and then I have x to the 4 plus 2, or if you want to write out, I have 4x's times 2 more. I have a total of 6 x's. So negative 3 times x to the 6th power is your final answer. The 7th example, we're going to multiply with more parentheses. So I just wanted to show you those so that it doesn't scare you if you see this on a standardized test or something like that. Okay, so this has your numbers. I have a negative 2, and I'm going to pull up this number right here, times a negative 2. Now usually when you see this, you're going to see a parenthesis around your negatives. You might see 2 parentheses. You might see a parenthesis there, and a parenthesis there. That just means negative 2 times negative 2. I then have x squared times x. And if you'd rather write x squared times x as x squared times x, you can. Whatever helps you get to the final answer, it does not matter. A negative 2 times a negative 2 gives you a product of positive 4, because a negative times a negative, anything that's the same when you multiply them, gets you a positive answer. And then x squared times x gets you x to the 3rd. Your final product is 4x cubed, or 4x to the third power. We're going to do one more example before you have time to practice. So the last example here, again, I just wanted to make you sure you see everything. So this example takes x times a negative x times a negative x. And I, again, like to put in my numbers here. So I have a 1, and a 1. And if I sneak those 1s in, and now I'm going to be careful when I rewrite them. This one is a positive 1 times a negative 1 times a negative 1. And then I have my variables. I have x times x to the fourth times x to the fourth. You don't have to put times signs in. If it makes you feel better, do it. If you want that variable with an exponent, add that invisible 1. It really helps when you get to adding so that you don't forget it. Now, your choice on how you multiply these. You have 3 numbers that you're multiplying. You have 2 negatives and a positive. 2 negatives times each other gets you a positive. This will be a positive 1. Then you're going to multiply by another 1 to get a final answer of positive 1. Then I do my x's. I have 1 and 4 and 4. So if I add 1 and 4 and 4 together in your head or on your paper, you get x to the 9th power. You can then simplify it to be finally x to the 9th. Nice job. You made it. How you feeling? The next thing I'd like you to do is to continue to practice. You have some options here. You can go to online games on the week at a glance. I have a Magna High and one other option. I'd rather have you do the Magna High. It's at a beginner level, and then it gets more difficult as you go. I am taking out this handheld card game. That's not going to happen today, but you do have the paper handout to finish Why Mr. and Mrs. Number Are So Happy. You can finish that puzzle, and that would also count as practice. If you are doing online games and you're doing the Magna High, I'll be able to tell because you're logging on using your username. If you're with a partner and you're working together, please make sure you tell me so that I know and give you credit. Thanks for being here. I appreciate your positive attitude and you working on your own to individualize your learning and personalize it. Appreciate it. Continue to practice. Thank you. When you're done with your practice, if there is time, please create a foil hat. On Monday or Tuesday of next week block, we are going to be foiling. And in order to foil, you don't have to have a foil hat, but it just makes it more fun. So if you forget, you can definitely do this weekend or on Monday morning. Please make sure you bring your foil hat to class. Thanks for being here. I appreciate your time. Good day.